Hello, this is Xander Richardson, and this is my culminating for the SPH4U physics. In my demonstration, I will show how gravitational fields, energy transformations, and dynamics all have an effect on the motion of a marble roller coaster. For my culminating, I'm going to show how a simple marble roller coaster can connect to lots of SPH4U physics concepts that we have learned over the year. I built this track using household materials. Now, it may look simple, but there is a lot of physics behind it. For my marble roller coaster, I am going to be focusing on 3 main units out of the 5 that we have learned. We have gravitational fields, energy and momentum, and dynamics. For this demonstration here, I have this ramp built with the starting hill, a downward slope, a smaller hill at the end, a downward slope going down the hill, and then the track eventually straightens out. Now I'm going to show what it looks like. Now here is a better angle. As this demonstration shows, it covers how gravity plays an effect on the marble, how static, kinetic, and gravitational potential energy also plays its part, and lastly, how dynamics, specifically Newton's second law, also comes into play. Now I'm going to break down each section with slowed videos, calculations, and explaining the concepts and how they correlate or appear in my demonstration.
Okay, first, let's talk about gravitational fields. Earth creates a gravitational field which pulls everything down to the ground, also known as gravity. This can be then calculated using the formula Fg equals mg. Or it could also be shown as Eg equals Fg over m equals g. For my calculations, I will be using force of gravity equals mass times gravity, which is Fg equals mg. Now, I have my marble weight of 0.020 kilograms, and I know the value of gravity, which is 9.8. Now, with these known values, I can put it through the equation Fg equals mg, which gives me Fg equals 0.020 kilograms times gravity, so 9.8, which using a calculator will give me 0.196 newtons of force pulling the marble down at all times. Even though that value of force seems relatively small, it is what keeps the marble moving throughout the track. Okay, next up, let's talk about how we can calculate the potential energy. To get this, we can use the formula potential energy equals mass times gravity times height. Now, I already measured my starting height, which was 3 feet, which comes out to 0.90 meters. So now we have everything to do this formula. So PE equals 0.020 times 9.8 times 0.90, which putting through a calculator will give us 0.176 joules of energy. At the top of the ramp, the marble has the most gravitational potential energy because it's at its highest point. That's calculated by PE equals mgh. I will now tell you how gravitational fields affects this demonstration and how they apply. Firstly, Earth creates a gravitational field that exerts a force on all masses, such as my marble. At the top of the track, the marble has gravitational potential energy because it is elevated above ground. As soon as the marble is released, gravity pulls it downwards, causing it to accelerate along the track. Now, since I already calculated the velocity, potential energy, and the force of gravity acting upon the marble, that is pretty much all that needs to be said about how this can tie to my demonstration.
Next up, let's talk about energy and momentum and how it comes into play. At the beginning of the track, the marble has mostly gravitational potential energy due to its height to the ground. As it rolls downwards, this energy is converted to kinetic energy, which is the energy of motion. The kinetic energy increases as the marble's speed increases. This can be calculated by the formula kinetic energy equals 1/2 mv to the power of 2. Alright, now we need to find the kinetic energy. which, as stated before, can be calculated using this formula, which we need to find velocity, as that is the only thing we are missing. Now, using the slow motion video, I took how many seconds it took for the marble to travel a set distance. It took the marble 3 seconds to travel 1.38 meters, which was from the top of the ramp to the bottom. And so if I go 1.38 divided by 3, that gives me 0.46 seconds. Now that we have the distance and time, we can throw that in the formula for velocity. So v equals delta d over delta t, which would equal 1.38 over 0.46, which would give us velocity equals 3 meters per second. Now that we have the value for velocity, we can use the kinetic energy formula. So kinetic energy equals 1 over 2, 0.020 times 3 to the power of 2, which would give us kinetic energy equals 0.09 joules. Now, kinetic energy is a bit less than our potential energy because some of the energy was lost to friction, heat, and sound. The marble also has momentum, which depends on its mass and its velocity, which we already know. To find its momentum, we can use the formula P equals mv. Now to find the momentum, we have the mass, so 0.020 kilograms, times velocity, so 3, and that gives us 0.60 kg times mass per second. As the marble gains speed, both its kinetic and momentum energy increase. However, some energy is lost due to sound, friction, and vibrations, which is why the marble does not return to its original potential energy. For my final concept demonstrated, it will be dynamics, which is the study of how forces affect motion. My main focus will be Newton's second law, which states that a net force acting upon an object will cause it to accelerate. This can be described using the equation F net equals mass times acceleration. In this project, gravity creates a net force that causes the marble to accelerate down the ramp. As the marble moves downhill, its speed increases because the component of gravity acting along the ramp is causing acceleration. In order for us to find F net, we first need to find acceleration. In order to find acceleration, we can use the formula velocity final minus velocity initial divided by t. Now we already know all these values are velocity final, which was 3 meters per second, minus our initial velocity, which is 0 because it's at rest, and divided by 0.46 seconds, which would give us an acceleration of 6.5 meters per second squared. The next thing we could do is find the theoretical acceleration, which is a equals g sine theta. For the theoretical acceleration, I'm going to compare it with my acceleration I got for the starting downhill ramp, which was 55 degrees. So I get acceleration equals 9.8 sine 55, which put into a calculator would give me my theoretical acceleration equals 8.02 meters per second squared. Now that we finally have our acceleration, we can find the value for F net by using the equation F net equals ma, which, filling out the equation, will give us F net equals 0.020 times 6.5. Which gives us a value of F net equals 0.13 newtons of force being acted upon the marble, causing it to accelerate down the ramp. When the marble moves uphill, gravity acts in the opposite direction of motion, causing the marble to slow down. By observing the marble's change of speed throughout the track, it is possible to see the relationship between force, acceleration, and motion in a real-world system. Now, in summary, this simple marble roller coaster demonstrates 3 great concepts in physics. Newton's second law of motion, momentum and energy, and gravitational fields. Thank you for watching this educational video.